Hooray! Half-life problems. Okay, so whenever you're working with a radioactive element, it's decaying at some rate and it's eventually going to try to get back to being lead. Anything above lead is typically radioactive. Um, so each radioactive element has a different half-life, and what the half-life really means is the amount that's remaining. Um, rather, it's the amount of time it takes for half of whatever sample you have to completely decay. That's what half-life means. Half of it's gone. How long did that take? And so each one of these radioactive materials has a different half-life. So in this example, we're going to be looking at a 20-gram sample of plutonium given a half-life of 30 minutes. So that means after 30 minutes, half of it's gone. How much is left after 3 hours? Okay, so there's a couple different ways you can you can solve this problem, and one of them is an equation. It's called fraction remaining. And that equals 1 over 2 to the n, where n is the number of half-lives. Number of half-lives. So in 3 hours, we'd have 6 half-lives because there's two 30-minute segments in an hour. 2 times 3 is 6 in this problem. But this is not the answer. This is the fraction remaining. You would need to take the starting material, the total material, times the fraction remaining, and that's going to equal the amount remaining. Okay, if you just do this fraction remaining problem, that's not the whole bit. Okay, so in this example, we know that if it's 30 minutes and this is 3 hours, we know that our n equals 6. So we take our total amount, 20.0 grams, times our fraction remaining, 1 over 2 to the 6th. And when we do that, this is the same as 20 grams times 1 over 64. And that gives us 0.313 grams that's remaining. So notice if you just took the 1 over 64, that's not the correct answer. You need to multiply the fraction remaining times the amount that you started with. Okay, so that's one way to solve the problem, but I'm much more visual. I like, which is kind of funny. I like to draw out absolutely everything. So I'm just going to give myself a little bit more space here. Focus on this. So the way that I visualize half-life is this. So I imagine it like a bar graph. So I'm starting with 20 grams of plutonium. And then after 30 minutes, so this is time 0. Time 0, that's when we start. So after 30 minutes, we've got half of it left. We've got 10 grams. And then we can continue on. Half of that would be 5 grams. And that's going to be after 1 hour. And we'll have 2.5 grams after 1.5 hours. And then half of that is going to be 1.25 grams after 2 hours. And then after that, 2.5 hours is going to give us half of that, which is 0.625 grams. And then when we're finally at 3.0 hours, that gives us 0.3125 grams, which is the same as that. So what I kind of do for myself is I make a timeline and I divide it by half each time. That is exactly what this part of the formula is doing. Right, so we've got 1, 2, 3, 4, 5, 6 half-lives. That's where this 6 comes from. Each half-life, we're taking the total amount and we're multiplying it by half, and that's where we get that number. So we'd have to do that 6 times for all these arrows. 1, 2, 3, 4, 5, and 6. And if we condense that, that's 20 grams times 1 over 2. There's 6 total 2's there, and that's where it comes from. So it's the same thing. It's just that I can see this better. This equation, That's my personal preference. Both of these will get you the exact same answer, 3.125, 0.313. They're the same answer. So moral of the story, there's more than one way to solve the problem and get the correct answer. Hooray!